Right, what I want you to do in this session is to learn all the properties of a square. So let's have a look. Let's try to make a square out of this. There you go. Right, there's a square. Right, we know it's got 4 edges, so this here is an edge. Okay, where 2 edges meet here, that bit there is a corner, but we call it a vertex. And if you've got lots of vertexes, we call them vertices. Vertices. So that's plural. Right. So let's do that again. So the first thing, oh, I didn't like that. Let's draw it a bit more carefully, or quicker should I say. There you go. Right, first symbol, all the 4 lengths, all the 4 edges are equal. Yep, all 4 edges are equal in length, and we show it with these little symbols. Let's get the laser out there, these 4 symbols. Right, let's draw another square. Right, so now you've got, I want you to know that the 4 corners of vertices are at right angles. 90 degrees, 90 degrees, 90 degrees, 90 degrees. So all 4 corners vertices are 90 degrees. So right, okay, another thing from that which you could learn or remember, so if I add up 90 plus 90 plus 90 plus 90, I end up with the inside internal angles add up to 360 degrees. That's a terrible zero, that. I tell students off for that. 0 degrees, that's the degree symbol. Right, okay, that's 1, 2. Let's do another one. Right, I want you to know that opposite sides are parallel, and you show them with these. Let's get the laser out. You show them with these arrowheads. Okay, and now these 2 are also parallel, but that would be confusing because that would show, or that would confuse people to say these 2 are not parallel. So what you do instead, on this side you put double arrowheads. So we can say, oh, we don't need that, opposite sides or edges are parallel. Right, what does parallel mean? Let's have a look at this. Parallel. I'll tell you what we're going to do is, we're not going to do that. We'll add a page and we'll call it, we'll add a page right at the top. Can we do that? Yeah, there you go. And we're going to call it definitions. I think that would be a good one. Right, let's try to write a definition for that. So parallel. I'm going to try to write in simple language if we can. When two lines never meet. Okay. You can say when two lines are equidistant apart or the same distance apart, but we'll leave it like this. I think otherwise it's going to get a bit complicated. Right. So I want you to copy these, and then I'm going to move down. So what we're going to do now is draw another square. The reason I'm drawing all these squares separately so we don't get confused. So I'm going from this vertex to this vertex, and I'm going to try to draw a straight line, and I thought it would turn it into a straight line, but nope, maybe not. There you go. That didn't work. What a disaster. Right, okay, the two lines that I've drawn, right, from non-adjacent, right, don't forget about that, as in, sorry, forget about that, don't worry about it. Non-adjacent means that they're not next to each other. Right, these two lines that I've drawn, this one and this one, are called diagonals. So we'll write it this color. We have two diagonals. We have two diagonals. Right, I just want to do one more, maybe two more lines of symmetry. So let me just draw another square, lines of symmetry. So I want you to learn all these properties, okay? If you can, please. Right, let's draw some lines of symmetry using this. Line of symmetry is if I cut the shape in half and I put a mirror down here. Let me get the laser. This half will be exactly the same as this half. Another way of looking at it, I'll show you, which I've seen it's a really good way of looking at it. If I've got a butterfly, so there's a butterfly, there's half a butterfly. It has a line of symmetry down the middle there, because if I put a mirror there, the other half will look exactly, if I get it right, the same. Yeah. Oh, it doesn't look the same, but you get the idea. Yeah, so that's your line of symmetry. And a square has four lines of symmetry. That's one down here, one across here, and it also has diagonal lines of symmetry. And if you notice, I'm drawing them as dotted lines. I think it's better to draw them with dotted lines. You have to excuse the straightness on that. So we can write a square has four lines of, right, we're going to say four lines of symmetry, but you can say four lines of reflective symmetry, but that might get a bit too much at the moment. So we'll say four lines of symmetry. Oh, let me get this right. Symmetry. Right, can I do rotational symmetry on here? Let me give it a go. If not, then I'll try to find something which shows one more property called rotational symmetry. Right, can I get another shape? Oh, okay. Right, shall we change the colour on that? No, I don't think I can. Right, okay. Right, it's going to be difficult this, so let's see if I can manage it. Can I change the colour on that? Rotate, no. Right, okay. So what we're going to do is, if we can, I'm going to put this across here. Right, if I rotate it, right, okay, so can you see I'm rotating it one full circle, so when I go round quarter of a turn, it looks like the same square that we started. You have to ignore that little gap. I didn't quite draw it accurately. 1, 2, it looks exactly like the original square. 2, 3, and 4. I've done a full circle. 4. Right, what I need to do is I find a video. If I can find a video, I'll show you that. Right, so what I want you to know, let's delete that. I want you to know, nope, what's going on? I'm falling off my desk. Right, I'm going to draw a little arrow like this, showing rotational symmetry. So a square has rotational symmetry order 4. Okay, so if you can copy all those, that'll be brilliant.